Alrighty. Happy Monday. So I think we covered everything we needed to in lists. We got that done on Wednesday, right? So we can talk about dictionaries today. Does that sound right? All right. So dictionaries are going to be a lot of fun. And you are going to love when we start doing. Oh, no, we didn't get to lists of lists, right? I think we waited on two-dimensional lists. You guys got to check me here. Let's see. Lists. We did. Oh, no, we didn't get to it. Okay. That's not in there. Um, You didn't. Okay, that's fine. We'll move to dictionaries. We do dictionaries of dictionaries. This gets to be lots of fun, and we'll also do lists of lists because those are fun too. Okay. Um, so looking at the rest of the semester already, if you can believe it or not. So next week on Monday, the plan is to do midterm review. So on Wednesday, I'll give you last year's midterm so you can see what the questions look like, how I write them, get familiar with it. It's half true, false, fill in the blank style, short and like here's a one word something answer question, about 15 of those or so, and then three long answer coding questions, like write something that does this. So we'll probably have a question on dictionaries, probably one on strings, and maybe one on lists, probably strings, lists, and dictionaries. They might use functions as well, like write a function that does this. And then, of course, it'll probably have a loop, it'll do some branching. Like we don't get to forget any of that earlier stuff. So I'll have three questions that are long answer that make up half the midterm and the other half for the short answer. Um, Now, I know not all of you are necessarily morning people, and 12:30 is still relatively morningish, depending on how much coffee you've had here. So my plan is to not sit and watch you take a test on 10:25 because that's terribly dull, and not everyone likes to take a test at 12:30 in the afternoon. That sort of timing. So at 12:30 on 10:25, I'll open the midterm, and then as long as you get it in by 12:30 on 10:30, October 30th, not 10:30 the time here, you can take it anytime you want to spend an hour and 15 minutes. So it'll be timed in Canvas. So you don't have the entire time to do it here, but any time in those 5 days that works well for your schedule, go for it. Now, I'm going to ask you to not work together on it, and I will trust that you won't work together on it. And then we can keep doing this sort of thing here, being flexible here. As long as no one spoils that, we'll be in good shape. It is open book, open notes, open internet, right? No one has ever asked me at my job to write something off the top of my head without using my resources, because that'd be stupid. I don't expect you to memorize anything, right? You have to know where the information is to go find it. And especially because it's only have an hour and 15 minutes, you've got to know where to go find stuff relatively quick, right? You don't have all day long to go and look stuff up. So, but go and find stuff online. Yeah,
There's the 1 hour saying solving law questions.
all of it. Yeah.
All
So it's 15 short answer, true, false questions, and then three coding questions. So
over the
it's like write a function that will reverse a list. Or, I'll give you my last semester's or last year's midterm here. So the goal is, I'm sorry,
that's like you that's not anything.
anywhere you want to do it, anytime. Yeah. So as long as you take it before 10:30 at 12:30 p.m., you'll be fine. So whenever you'd like to sit down, wherever you want to be comfortable sitting down, taking it, you're fine. Um, Yeah. So the goal is that the long answer questions take 20 minutes or less. So ideally, they're like 10-minute questions. And then if you need double the time, you can have 20 minutes per question. That takes up an hour. Then you got 15 minutes for the 15 short answer questions. Just kind of work through them pretty quick. They're not super long. So I can pull up last semester's midterm later. But on Wednesday, I'll show it to you. Then on Monday, we'll go over the solution to it. And then, so I think the plan, let's see, do we need lab? So we're going to do our lab on lists. Yeah, we'll do a lab on lists today, and then next Monday we'll do the lab on dictionaries. Because I think we can split those up here and have some fun with lists, and then next week have some fun with dictionaries for lab. So we will do lab on 1023. Yeah,
So next Wednesday, what do we do in class?
nothing. If you'd like to take that hour 15 to take the midterm, go for it. If you'd like to take it at another point in time, go for it. Wherever you want to be. So there's no plan to meet on 1025. And I'll post a reminder in Canvas so you don't come in for that part. So I find it terribly dull watching people take exams. And like my 11 a.m. class, taking an exam at 11 a.m. is awful. That's just not a good time to take an exam here. So whatever works for you, that's great. Uh, and then moving on after that, we only have a couple more chapters of new material that we get into. We start the final project around 11:15 or so. So mid-November, we start the final project. And then um, I screwed something up here. Hang on. Where's Thanksgiving? Did you guys not notice this? Hang on.
So usually by the end of the mid.
Yeah, we're off, aren't we? All the 18th to the 26th we're off. Oh, I just didn't put the weekend. No, no, this one. We don't meet this week. Shoot. Okay. Um, wow, how did I miss that? Sorry, let me go and change that here. That's that's no fun. So it's not a big deal. The inheritance section we get into as a major topic next semester. So we just kind of touch on it here. So I think we'll be fine bumping that down to this week here. So this is inheritance. Can't spell. Goodness. That's chapter 13. So this is Thanksgiving week, Thanksgiving break, right? Nothing happening that week. You get the whole week off for break, right? Which is great. Oh, now my table doesn't fit on one line though. That's really ugly. I don't want the last like line of that table there. That's fine. That's fine. Whatever. It is what it is. All right, so we go add that new version here. I'm sorry about that. I totally missed that week. Did I drag it there? Drag the file there. Replace. Okay, this will be a little better now because we have Thanksgiving break. Okay, it won't load. That's fine. Pull up this version. Oh, it finally loaded. Look at that. I just have to wait longer. All right. So after we get back from midterm, right, we've got classes, exceptions and modules, files. Files is a lot of fun. I love files. And then we'll start the final project. We're off for break. We get a week on new stuff here. And we just sort of touch on these topics. Inheritance and recursion are topics we cover deeper next semester. We just want to talk about them a little bit here. Some Python for data science is really fun stuff. We're not going to get deep into, just kind of intro the topic. And then first week of December is set aside for final project work time. So I don't have any plans to talk about anything. It's for you folks to work on the final project and me to be able to help you with it. Get you pointed in the right direction here. And then when we do our final exam slot here, we're actually just presenting our final projects. So you guys will go up and be able to show this is what the final project does. Run your code. It might be a question or two. It takes 10 minutes or less. It's pretty painless. But I want you to have the experience and start getting used to presenting in front of your peers because you'll do that in the workplace. Right? You'll work on a project and you'll have to show it to your team and say this is what it is, right? And get some feedback there. So this is relatively I mean, it's a large part of your grade, but like low stakes, and there's no points for presenting. There's no points for you don't need a PowerPoint slide deck or anything. We're gonna run your code, and they'll ask you maybe a question or two about it. So it's pretty painless here as we go. So ideally, you can get it done by 12:6. Might not happen. That's okay. But if you get it done by 12:6, because we've had enough time to work on it, then you don't have anything to worry about for final exam week except for your other final exams. And then you can just show up and run your code, and life is good. That's the goal here. I'd like it to be as painless for you as possible so you can focus on the other classes. So we'll see. Because I don't expect everyone to do like take the whole week off for Thanksgiving break. I apologize if you do want the whole week off, you can, but you'll have to work on the final project the other weeks then. You have a question?
Yeah, so not very good $3 for that. Present it.
We've got the whole 3 hour block. We only have 10 people in the class, so it should take like maybe an hour. So usually less than that. So, and for final projects, I'd love for you to work in pairs, but I don't require it because it's not an outcome of this class. But I think working with a partner gives you a better product, gives you a chance to see what it's going to look like in the real world. Because working by yourself is awfully lonely, and then your code's not going to be as good. So it's just sort of how that works. So if you'd like to pair up, you can pair up. You don't have to. And if you do pair up, it actually takes more work because you have to coordinate who's doing what and talk about it. And so you do the exact same project, whether or not it's individual or with a partner, because partners actually have more work that they have to do together. So it works out to be about the same amount of effort, whether or not you do by yourself or with a partner. Um, yeah, so that we'll do our presentations on 12:13. is the goal. Yeah,
No, five times, rather it says finding point against it.
yeah,
That one, it's like, where it's the floor.
yeah. That's. I'll give you what the final project is on 11/15. So we'll have about a month to work on it. Yeah. So because it does make up 40% of your grade, right? This final project. The idea is if you don't do the final project, you don't pass. Right? You can do badly on it and still pass, and that's okay, right? If that's your goal, you just need passing, that's okay. But you can't skip it, right? That is the bulk of your effort here. And this is our first coding class. It's not going to be anything amazing, but it'll be something I find it slightly interesting. Whether or not you do is another story. But that's okay. Yeah,
So, project travel, we, you not have people speaking back.
I'm sorry.
For projects, we don't need people say back.
The labs, you mean?
Then project.
The regular projects. So I look at them. We're trying to do this ungrading sort of thing. So when you do your self-assessment, you generally get that score unless you just completely lied about it. Right? Most everyone's pretty good at scoring themselves. So generally, I just post that score. I'm behind on actually posting them in Canvas. I'm sorry, but that's why I give you the rubric, and you go through and say, okay, I did this, I did this, I did this. Maybe I only got part of this, and however that worked out is great. So I look at your code, looks reasonable. If you want to like take a dive into your code, meet with me sometime. We can go through it side by side. I'm happy to review it that way. Um, so I can give specific feedback like that if you'd like, but I generally don't go and mark it all up and post it in Canvas. Be like, here's a big document of marked up stuff here. Um, so does that make sense? Okay, cool. All right, so that is about the end of the semester as we're looking at this now, right? We'll do our midterm, we'll come back basically November, and then not much in December, just wrapping up the final project here. And then we look forward to winter. So I did hear the advising office, someone, I forget who it was, came out to my other class to remind everybody you have to meet with advisors to register because you probably have an advising hold for registration. So they keep posting all these things. I don't know if you're getting emails about it. Go schedule an appointment now to meet with the advisor to plan your winter schedule. Make sure you get the right classes because otherwise you won't be able to register, and that sucks because you want to be able to register as soon as you can to get the classes you want before they fill up. Um, so make sure you go and do that. They've got like peer advising groups or I don't know, a bunch of stuff going on, and then they actually have like a workshop day I posted about in Discord. You can go take a look at that too later if you want. Should be a lot of fun, but definitely registering early is better than late. I think they targeted my other class. It ended up being a sixth section of that class because we have so many people want to take it. And they essentially, because they were in the sixth section, were the last people to register. So they're like, hey, we should probably tell the people who registered last semester to go and register early for winter so they don't register last again. So I don't know when you guys registered, but we should be in pretty good shape. All right, so let me fire up PyCharm and we'll go from there. This is going to be chapter 8. Go. So we start a new project. Let's do chapter 8. Dictionaries. All right. So we've worked with dictionaries, right? This is the name or a key with an associated value. Right? So I have a unique set of keys, and I get values associated with that set of keys. Right? And the reason they're unique, right, is add and update is the exact same function. Right? So if I were to say, hey, this is, I don't know, let's call this the grade book. Oh, grade book. Here's the dictionary. And I can say grade book, key of Eric, assign a value of A, because of course Eric has an A. Because I score myself, right? You guys all have A's too, right? Because you score yourselves?
That's it.
uh, so if I wanted to update that and say, oh no, maybe I had a lot going on and I didn't get to something, so maybe I only have a B here because I didn't do so well in that other project. This one is the add. This one is the update because the only difference is it already exists here. If it doesn't exist, it adds, right? If the key doesn't exist, it adds. And update, if the key does exist, right, it updates. So the format is the exact same here for add and update. So you can't have two different Erics, right? It has to be a unique set. You only get unique sets, unique values for keys here. And then we can add other people to the gradebook. We can add Jeb. Jeb maybe had the B. Doesn't like doing his homework. Maybe probably has a C. She even less likes doing her work here. Then I'll add Journey. Journey's doing really well. She loves school. She'll have an A. So I'll have a couple different keys and associated values here. Now, ways we can work with the dictionary, right? I can loop through the keys. I can say for name in gradebook, right? This will loop through each key. Will be called name in the loop, right? So I'm just saying I'm going to call the thing here name, which is a key, because that's what the keys are in my gradebook, right? It's just a variable name for it here. And then I can print, I don't know, let's do name, comma, and then gradebook key of name will get the value associated with that key, right? So I'll get the name and their score. Um, so I should be able to get all of these back out with the letter grades. Nothing new here, right? Loop through a dictionary, build out our dictionary. Okay. So if I want to have a user work with this instead of hard coding all of it here, right, we could do that sort of thing. We could say, how about a little loop? So we'll have name as an input, enter a name to add to the gradebook. And then now I probably want to check and see if this name already exists to tell the user this name already exists or not, just to be useful here. So I can say, hey, if name is in the gradebook, I can use the in operator. This looks for a matching key. Key only. It does not look for matching values. Only looks for matching keys. Right. So if name is in the gradebook, then I can print, or I don't know, we'll get a score or grade is an input of enter the grade to update for plus name. Right. If we're doing inputs, I can't comma separate. I have to do the appending here. Right. And then otherwise, if it's not in there, right, we'll say grade to add for. I don't know if that makes any sense. So we're going to specify this is an update or an add as we go here. And then I can say my gradebook, key of name equals the grade. Right? Whatever grade I got here, whether or not it was add or update, I'm going to assign to the key, right? Associate with the key of the name here. And now maybe all of this happens, right? How about while name does not equal quit? There's probably nobody named Quit in your class, right? That'd be a really terrible name to give a kid. Poor little Quit here. So I'm going to say name equals nothing here. Named out of the gradebook or quit here. Now the problem is I don't want to add quit to the dictionary, right? I don't want to ask for a grade for quit. So all of this happens, right? If name does not equal quit, um, right? That all happens if name is not quit here. Sure. I've got to kind of repeat it here, and I'm not so happy with having to repeat it here, but I don't have tons of options as we go here, right? This is something's gonna have to get repeated. Yeah.
Like, agree, and like that. You have to receive doesn't have a button or have a just.
So I'm using the plus to append the string together because with inputs, you can't just print and comma separate. Like when you print, you can comma separate values. And print will say, okay, take this value or take this value or take this value. Here, with input, it has to be a single string. So this is actually getting concatenated, right? String and string get smushed together, and then it will use that as the prompt for input. That's why I have the plus here. Yep. Cool. So eventually now, when I'm done, I can just print the gradebook. Now, this is not going to be the prettiest looking gradebook here, but we can do it this way. All right, so let's give it a run. So we got our initial versions here. So enter a name to enter the gradebook. Let's say Jubilee wanted to join the class. She gets an A, so let's give her a B. How about a B plus? And then how about we update Jeb? Now, lowercase letters and uppercase letters are different, right? For keys. So uppercase J, Jeb is an update. Let's give him an A this time. Lowercase j, Jeb is new, right? Because it's not the same letter here. That sort of thing. And then quit. Eventually, I'll get here's key colon value, 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 key colon value. Right? You can print it out, and you get this gradebook or the dictionary looking format here as well. So we can work with our gradebook, right? Adding values, updating values, that sort of thing as we go here. All right, so let's see our dictionaries. Dictionary types, key and value. You can delete here. This one is not as common to use the del keyword. We've got other options for removing from our dictionary, but that's fine. Look at this. We can modify, delete, print student grades. We've got a little grade book here. How awesome is that? So for methods here, more often than not, um, you can use pop to remove. Pop is probably more common to remove. The other cool thing you get to do is you can give it a default if you want. So if it doesn't exist, you can get a default back versus it just crashing. Or for get here, instead of using that syntax, we can get a default value out, right? Say, hey, if I don't get a result back, give me NA versus if I don't get a result back, it just crashes on me, right? If I try and get the gradebook key of something that doesn't exist here, if I were to say like print gradebook key of Jasmine, it's going to crash on me here because that key doesn't exist, right? It says key error, Jasmine. Key error, the key didn't exist. So you could check, you can say, hey, if Jasmine is in gradebook, you can protect it this way. Or we could say print gradebook dot get key of Jasmine, and then default of, I don't really, NA, I like NA, right? And now we get, hey, there is no grade here, right? So get gives you the option allows you to not crash and give a default. I think if we don't give a default, what happens if we don't give a default? I don't remember. Let's try what we get here. Yeah, so if you don't give it a default, you get none, which is technically a default as well. So you can specify the default you want, right? NA is probably nice, a little bit nicer here. But so get won't crash, right? Versus just getting it by key value here will crash. This method will crash. The key doesn't exist. So depending on how you want to work with it, you can either check with an if it's in, or you can use the get to get default values out. Either way is going to work for you here as we go. The update here is says, hey, let's take two dictionaries and smush them together. Add everything from the second dictionary into the first one, right? Sure, you can smush two dictionaries together. So there's some options here. So when we iterate over the dictionary here, right, for each key in the dictionary, we can do something. Now, we don't always get the value back out, though. Right? The order is not guaranteed to be the same. It takes a little while for us to get something out of order, but eventually we will. Behind the scenes, this is because hashing, we talk about this more next semester, and it'll make a little bit more sense. Just for now, know that the order is not guaranteed. Just because I put them in this order does not mean I'll get them out in that order when I loop over it. Uh, so if you want something in a specific um, order, you can sort things. So you can get the items, which are key value pairs. You can say, hey, for each soda, comma calories in the number of calories dot items. This will get you key value pair. So the first thing is the key, the second thing is the value. So we can get both key and value at the same time. If you want, like when we did enumerate, we got the index and we got the value out of a list. Sort of like that, we're getting the key and the value. If you just want the keys, right, you get the key out, right, which you don't need to do this separately because that's what you get normally with the for loop, right, for key in dictionary. So this one's a little silly here, but you can specify just the keys. And then the values, you can get just the values if you want with the values list. Now, why keys might be useful is if we want to sort it. Remember, we can sort lists really nicely. So if I wanted to sort my gradebook alphabetically here before I go and print it out here. So maybe we'll say for name in gradebook.keys. Now, I can't sort right away. If I hit dot, I don't get a sort option here, which is a little weird. But I can say sorted keys. Print name and gradebook name. Right. Print the key and then the value here. So this gives you a sort the keys this way. So sorted takes something that's iterable and sorts it. Dot sort only works on lists. So dot keys doesn't actually give you a list. Is the the reason why you have to use sorted here. So it's a story. It's okay. Don't worry too much about it. We get more into it next time. I think we give this a run. We'll just say quit. And now we get them in alphabetical order, right? Different than the order I had them in before. Close, but a little bit different, right? It's before looping over them or iterating over them, right? That's the proper word, iterating over them. So this is why keys might be useful if you want to sort it. Otherwise, just do the regular list or just do the regular thing here and just get them out in whatever order. If the order doesn't matter, go for it. If the order does matter, then sort them if you want. So that can be useful here. Um, oh yeah, here's the sorted thing. You can make a list of it if you want. You can say, hey, give me the list of those values. Not too interesting. All right. Here's where it starts to get crazy. We can put dictionaries inside of dictionaries. So this is a nested dictionary. So my key might be the student's name. The value associated is another dictionary that will have grade and student ID. Right? So I can store more than one piece of information about this student. I can store a whole other dictionary. I can have your grade, I can have your student ID. Maybe I have a list of the classes you've taken. Maybe I have transcript and whatever sort of stuff I want to have, I can throw into another dictionary that's associated with your key here. So to do that, then, instead of just assigning a single value here, we would assign a dictionary. So I say, hey, key of, I'm going to say this will be grade colon A, right? Assign a dictionary, the key of grade, associated value of A. And then this was a B. This was a B as well. This was a C. This was an A. Oh, it hates my spaces. I love spaces. Spaces are nice. So updating here gets to be tricky. If I only want to update the grade, I could do that as well, right? I could also say gradebook key of Eric. This here gives me a dictionary. That dictionary key of grade equals a B, right? I don't have to update the entire dictionary. I can update the value associated with the key associated with this key. So this is like a dictionary inside of a dictionary. It's a nested dictionary. So go to the gradebook dictionary, get the value associated with Eric. I know that's another dictionary, so get the value associated with grade, update that value to B. Right, so this is a two-dimensional dictionary, right? A dictionary in a dictionary. This gets to be a lot of fun. So we'll work more with these in the lab next week when we do practice more dictionary things. The lab this week will just focus on lists. So we can put lists inside of lists as well. Gets to be really fun. So you can go nuts with these sorts of things. Like, hey, here's my student, here's their homework scores, here's the midterm score, here's their final score. Here's their homework score, here's the midterm score, here's the final score. Right? And we can loop through and do all sorts of things here and get all their values as we go. We can put dictionaries. So this is a artist, this is an album, this is the song information for the album, right? So this is a dictionary with a list as an associated value. Oh my goodness, right? Dictionary is the music, dictionary for the artist, dictionary for the album. So this is a dictionary in a dictionary in a dictionary. And you can nest these suckers as much as you want. Now, I don't recommend it. This, like, at this level, my head already starts to hurt with three dictionaries inside of dictionaries inside of dictionaries. Right? This is just awkward already. We don't know a better way yet. We'll get to a better way yet. Let's see, where do we get to? When we get to classes. Yeah, next chapter. We'll learn a better way to do this. Classes are amazing. We're going to love them. But you can do this sort of thing if you want. And this is a great way to kind of group data together and associate values with them. Okay? Justin Bieber, his songs, his year, Platinum is True. Definitely a platinum album there for Mr. Bieber. My daughter loves him. Just it's music on all the time. I'm a little tired of it by now, but that's okay. All right. So we can do those sorts of things. Does this make a little bit of sense? We'll spend more time on this next week in lab too, and we'll practice dictionaries and dictionaries. So I want to shift back to lists. Can we shift back to lists? Because that's what we're going to practice our lab on here. All right. So let me go back and open up that other project here for chapter 8 lists, and I'll commit this one here for dictionaries. 2501. Dictionaries. Okay, so for lists here, we have just lists. We got a bunch of stuff. If I want to make a list of lists, right, a two-dimensional list, we can do that sort of thing too. So we can say, how about this is essentially a multiplication table. Multiplication table equals a list. Now the values inside of this list will be another list. Right? I'm going to do 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And I have my spaces here. Okay. So there's the list inside of that list. The next list, so the first value inside of this multiplication table list, this is at index 0, is another list. Okay. The next row here then is going to be 0 and 1. And now I'm going to have, oh no, I'm sorry, this should be 1, right? Because I'm doing my multiples here. 1 times 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. And then I have 2. 2 times 1 is 2. 2 times 2 is 4. 6, 8, 10, 12, 14, 16, 18, 20. Now this starts to get a little awkward here because it's not lined up quite right, right? Why is it upset about that? That's all right. And then 3 is 3, 6, 9, right? On and on and on. 12, 15, 18, 21, 24, 27, 30. This is super exciting stuff, right? As you can imagine, we could keep going as far as we wanted here for a multiplication table, right? Building this out by hand is awful. I'll show you a shortcut in a minute. But if I wanted to get at a particular value, right? Oh, I need my commas here. That's what I need. There we go. That's why I was unhappy. So multiplication table, index of what? Yeah,
Why would we call
because these are individual values that we're comma separating inside of this list, right? The outer list has comma separated values, right? I would say like, here's, list, my list equals,
list or like elements?
yeah, yep. So it's a list of lists. Yep. So the first thing, generally, we like to think of these as rows and columns because that makes sense to people, right? We like two-dimensional things that are rows and columns. In the computer, they're just one big old row essentially here. But I like rows and columns, and most people think of them rows and columns because it makes our life easy. So what row do we want? Do we want row at index 0? Right, this is index 0. Index 0 row. Right, this is index 1 row. This is the index 2 row. And this is the index 3 row. Right, so if we wanted to say what is 3 times something, that's at index 3, right? Then what column do you want, or what index of this list do we want here, right? Column 0, column 1, column 2, column 3, column 4. Oh, we don't need zeros. That's what I was doing wrong here. Right, there we go. I think the 0 was screwing it up. That was confusing me. Okay, right? What column do we want? Well, if we wanted 3 times 7, right? That's at index 0, 1, 2, 3, 4, 5, 6. So the value at row 3, column 6, right? Row 3, column 6. And these are indexes, right? Right, indexes is going to be 21, right? So maybe we could print that. So this is going to be 3 times 7 is the value at row 3, column 6, index 6, which actually is the 7, right? That's our value here. Off by, there we go, off by a space. So if we run this one now, we should get 3 times 7 is 21. Life is good. Why my Zoom is not working very well? There it is. Okay, so building this out by hand is really annoying, right? Doing it with a loop here is a little bit trickier, but we can do it. So maybe we scratch this here. So we'll do a multiplication table dot clear. We can clear it out. We'll empty it out. And then we'll say for value in range. Now I want 1 to 10. So 1 to 11 gives me 1 to 10, right? Right, gets values 1 through 10 because we don't get that last value. Okay. Now the first time, perfectly fine. Right? Nothing needs to change here. Oh, I guess I have too many rows here. What am I doing? I don't know how to build multiplication tables. Sorry, that's actually row 2. Yeah, I'm super confused. There we go. For some reason I thought we wanted like headers and footer, but this is the header and this is like the column header. Okay. So for value in range 1 to 10, I'm going to do another loop here inside of this loop. I'm going to say for this, so this will be, how about this is uh, the row here, and then this is the column in range 1 to 11, right? Again, gets the values 1 to 10 here. Now, because my multiplication table is clear, right, or it's an empty list, there's nothing in it, or maybe we can just set it equal to an empty list to start. This might make more sense. I need to add a row so that I can start adding something to that row. Right, so I'm going to take my multiplication table. I'm going to append a list. Okay, so this adds an empty list for the row. Okay, so at row 1, I now have an empty list. Now, for every column, I need to add the values to that. So I'm going to take my multiplication table, index of the row number. Right, so when it's row 0, I'm going to get to row 0. Now I can start appending. This is going to be my row times my column. Right, at 1 and 1, I add a 1. At 1, column 2, I added 2. At 1 and 3, I add a 3. At 1 and 4, I add a 4, right? Then when row goes to 2, right? Now I'll add an empty row for row 2. I'll have 2 times 1, 2 times 2, 2 times 3, 2 times 4, 2 times 5. Right? And when we're done, we can print the multiplication table. Now this is not going to print really nice here. Oops. But that's okay. I'll show you in a second. When I run this code here, oops, list index out of range. What? Oh, yeah. Sorry, so not row. This is row minus 1. Yep. Because I don't have index 1, right, at row 0. It's row for number 1, but that's actually an index 0. All right, let's try that. Okay, so it looks really long and ugly here. So that's not great. So I could say, how about for row in multiplication table, print the row. Because we don't want faces, right? So for every row, right, for each item in this table, let's print that item, and then go to the next one, go to the next one, go to the next one here. Oops. Hey, we got our table though, right? So here's our multiplication table. And I think that matches, right? 1, 2, 3, 4, 5, 6, 7, 8, 10. I think that looks good. No errors, right? 10, 81, 64, 49, 36, 25. Yeah, our squares look good. I feel pretty good. Okay, so we built out a list inside of a list here for our multiplication table. So if I wanted to ask someone, hey, give me a row and give me a column, or give me a number and give me another number, right? So I could get a first value equal to input of enter first multiple. Is it multiple? What do you call those things we're multiplying? They're multiple, right? Sure. And then second value. Now this needs to be an integer though, right? An int of that input. Because I need to work with these as indexes, int of an input, enter the second multiple, right? I can print out first value times second value is, and then I'll go to my multiplication table, index of first value minus 1, right? Because if you said 1, I need row 0. If you said 10, I need row 9, index 9, right? This is offsetting for my indexes here. And then what column in that row? Well, same thing here. Let's take the second value, minus 1 for the index. So if you said it's times 7, that's going to be in column 6, right? All of this to get a terrible way to figure out how to multiply numbers here. Let's give it a run. So what's the first number? What should we multiply? What times what? Let's see if it works. 4? 4 times 4 times 8. 4 times 8 is 32. It works. Again, it's terrible here, but using the row and column notation, right, we can figure out where that value is. Now, just like with dictionaries, you can put a list within a list within a list and go to the third dimension if you want, right? And then now you start to have that z-axis, right? We had xy for row and column, now we have a z-axis. I have a real hard time with that. because it just hurts my head. And I never took through multidimensional calculus, so never got good at visualizing these things. Eventually, you might take Calc 3, and then you'll learn to visualize these things in your head, and then you'll be great. I never did, so never got there. So we can put lists inside a list, inside a list, inside a list, inside a list, inside a list if you want. You can go nuts. Again, once you get beyond that third dimension, you've probably done a bad thing, right? And there's probably got to be a better way to do this. And we'll look at better ways as we get there. But once we have lists within lists, we can actually do something fun. So let's go out and build tic-tac-toe. So we'll have a board here then to play tic-tac-toe, right? You have a bunch of spaces, right? That's the empty row. So that's a row inside of a list here. And I'm going to comma separate. So I'm going to have three of these. Now, generally, I like to put them all on the next line here because it makes it look prettier in my head. They don't have to go next line, next, like, you don't have to lay it out like row and column, right? Now, Python generally is unhappy about white space, but because we do rows and columns for lists so often, it can figure this out, right? Generally, it all has to be on one line, right? Or if you add the backslashes, the fine folks in Python realized everybody thinks of multi dimensions with as rows and columns, so it can handle this format, right? Otherwise, it'd just be like uh, this way here, and this hurts everyone's head to look at this, right? This is perfectly fine. Does the exact same thing here, but which one of these do you think is a little bit nicer, right? It's this one. Okay. All right. So we have the board. Now, how does tic-tac-toe work, right? Let's just think about this in English for a minute here, right? You play until the game is done, right? So how do we figure out if the game is over? So let's define a function called game over, or is game over, right? Is game over. That would take a board. Now, I am a big fan of passing arguments to functions. So if you want to know if the game is over, you have to give it a board for it to look at. I don't want to do the global variable thing because that's ugly, bad habit, bad practice. So give it a board. Let's see if the game is over or not. All right. Well, how do we know if the game is over or not? We know whether or not somebody's won or it's a cat's game. I don't know why they call it a cat's game, but it's a draw, right? So we can return. We can say, did someone win given the board, or is cat's game given the board, right? We can make more functions here. We're doing functional decomposition. We're going to break this down step by step by step by step by step here. Sure. So we got to write those functions. Now, I'm not fond of typing more than I need to here. So I'm going to click my little light bulb here, and I'm going to say create a function for did someone win. I'm going to come over here, click my little light bulb. Come on, light bulb. There it goes. Create function. So it calls the function and returns what that function gives back. So these functions will return a true or false here. So I can have a true or false, or true or false. So the is cats game is pretty quick, pretty easy here. So to determine if it's a cats game, none of these can have a space, right? If there's a space, the game's not over. It's not tied yet. It's not a cats game if there's a space. So I can say for row in board, if there's a space in the row, return false, capital F false, right? The space there, right? If I find a space in any row, return false for cats game, right? If I
What if workspace keyboard?
So the board is each individual row, right? This is a row, or this is a value, this is a value, this is a value. So if I say, is there a space in here? It's never going to be true because there are lists there, and a space is not a list. So I have to go into each row to find the individual values back out here. Yep. So if I go through all the rows and I haven't returned false, then it must be true, and I'm going to return true, right? If I've not returned a false, I didn't find a space, right? Didn't find a space. Must be true, right? Because as soon as you hit a return, it's done. Okay. Now, did someone win gets a little trickier here, but it's doable. Okay. Um, Now, I'm going to break this down even further because I don't like doing lots of things in different functions here. So I'm going to return, did someone win horizontally, given the board, or now I'm just going to go down another line because this gets really long. Did someone win vertically, given the board, or did someone win diagonally, given the board, right? I'm going to break that down because we can turn this into multiple steps, right? figuring out if someone won is a big problem. It's a little easier to check horizontals, to check vertically. Did I not? I didn't retype that vertically. Thought I did. Or diagonally, right? Those are the three different ways you can win. So I'm going to break those down into separate steps. So let me go and add function. Let me go and add a function. Come on, come on. Show a function. Show, show, show function. There we go. Okay. So now I have all horizontal. Did I spell that wrong? Or is, oh, I did. So if I rename it here, I have to go rename it here too, right? So I want to be lazy here. I'm going to refactor rename. So I'm going to say refactor rename horizontally. Oh, goodness gracious. Nope. Refactor rename. Sorry, it's in this. Nope. Goodness. Horizontally. Okay. So refactor rename renames it both places. So I don't have to copy paste. All right. Diagonal is probably actually the easiest one to look at, right? So first, I'm going to look at the center because both of these will go through the center. So if the board at row 1, column 1 does not equal a space, right? If it's not a space, it's either an X or no, right? If there's a space in the center, you cannot have one diagonally, right? That 1, 1, right? 1, 1 being row 1, column 1, right here. If there's a space here, you can't have one diagonally, okay? So if it's not a space and my board at 0, 0, right? So 0, 0 is top left. Now, we are not math land. You don't have an origin at the bottom left. This gets to be a little awkward here when we start talking about two-dimensional lists, right? In math land, 0, 0 would be the bottom left. We're not in math land anymore. Row 0 is the top left, column 0, right? So just think about that for a minute. Like we're top left because this is 0, 0. This is how we count in PC land. Okay. So if the character there is equal to the character here, right? So if it's not a space and this one matches this one, and my board at 2, 2 matches the center, right? If the center is not a space and the top left and the bottom right match the center, that's a win, right? Somebody's won. I don't care if it's X or O's, right? I just know somebody wins, right? Right? Okay. So that's one way. That's the first diagonal, right? Or here, that now I don't want these ones here. Now I want row 0, column 2 matches the center, and row 2, column 0, right? So 0, 2 is this one, right? Column 0, row 0, column 2, and row 2, column 0 is this one. So I can check the other diagonal, right? Now, not that and this or that, right? I'm going to throw in a lot of parentheses here because there's nothing hurts to add parentheses. It doesn't never hurts to add parentheses, right? To be explicit here. So this one here or this one here and this one, right? So do these ones match or these ones match and it's not a space? That's my diagonal. And I said that's the easy one. I felt like that one was easy, right? It's either these three or these three. Does this make sense? All right. So how about vertically? All right. Well, I'm going to say for column in range 3, right? It gets me values 0 to 2, right? I'm going to, I can say if my board at row 0 at the column does not equal a space, right? And my board at row 0 at the column equals my board at row 1 at the column, right? So if it's not a space and they match, row 0 row matches row 1, right? And my row 0 matches row 2. Let's just bump these down a line here. Let's do 0 matches 2. It doesn't really matter which one we pick here. Right? So for each column in range 3, so at column 0, does row 0, column 0 not be blank? And does row 0, column 0 match row 1, column 0, and row 0, column 0 match row 2, column 0? If that's true, I'm going to return true. Then I'll go to the next column, look at column index 1, then look at column index 2, right? So look at this vertical, look at this vertical, look at this vertical. If I haven't returned a true, I can return false, right? I didn't find a matching vertical, right? So same thing with the horizontal now. Okay, so for row in board, now this one we can do individually as row if you want, right? We don't necessarily have to do the 2 dimensions because I can get out each individual row at a time here if we want. So I can say if my row at 0, right, because this is the individual row now is a single list, does not equal blank, and row of 0 equals row of 1, and row of 0 equals row of 2, return true. If we haven't found a match, then we're going to return false, right? So to check horizontally, check each row. Is it not blank, and do they match, right? Now, some people might be tempted to write it like this. Do you think this is going to work for us? I'm sorry?
Would be easier.
It would be easier, but is this going to work for us?
No.
We can't do this. Sad. I don't think we can do this, actually. We should test it, shouldn't we? Let's try it here. Let's go to, we'll just say row equals X. I'll do O's. Right? O, O, and O. And let's print. What do you think we're going to get? We didn't even print anything out. What? What? All right. Yeah, I'm so confused here. Print. Yes. Else. Print. No. It's not even printing it. What is it? Oh, we file didn't compile here. Where is that? Line 27. Oh, so we don't need an if here. I can just return this, right? If you're going to say if something return true, else return false, just return the thing. Right? It saves you a little bit of time. Okay, let's try that again. Oh, it's a yes. It did work. That's super fascinating. Okay. So we can do that shortcut. I'm very excited. Okay. I learned a thing. All right, so let's skip that then. So then we can do equals that.
So you're pretty much comparing lots of things.
Yeah, we're comparing this one equals this one equals this one. Do they all match? That's fun. Okay. So we can skip a little bit of typing here. That's super handy. All right, we'll do a little shortcut. Oops, bored of that. I think this ought to work for us then. I'm super happy. And the board of 2, 2. No, 2, 0, right? Yeah, there we go, 2, 0.
Well, so I didn't get with this one.
So saying this one equals this one equals this one is the shortcut. Instead of saying this equals this and this equals this. Right? It's going to infer that it wants us to do that. I thought Python was pretty smart. That's fun. Okay. So we can check, do they all match here? Do they match? And life is pretty good here. Okay. So that's our is game over. All of that now to get is game over. So we can pretty much say, here's my board. Right? I can say while not is game over, given the board, right? As long as the game is not over, we keep on playing here. And we'll say, hey, the current player, X always starts, right? So while the game is not over, we need to figure out where the player wants to play, right? So we need to get a location. So we'll say get, how about This is row and column, maybe? I don't know. Or how about make move or something? How about make a move, given the board? Now, this also needs to know the current player, right? So we'll call a function for make a move. Ask them to make a move, right? Given the board and given the current player. So let's add a function for this. So make move, given a board and the current player, needs to get the row and column, right? So I'm going to say, let's see, let's get the int, the row is int of an input, enter the row number. Now, we want like 0 to 2 because that makes more sense for us. If you want to ask 1 through 3, because most people number things 1, 2, 3, you can do that and adjust. I'm just going to assume this is easy here. The column is equal to an int of an input, enter the column number 0 to 2. We probably need to print the board too, right? So we'll say print board, given the board. Now, the reason I want a function here is if I just call print and I give it the board, right, it's all stretched out. And I don't want to have to say for row and board print, right, because I'm going to print the board multiple times. So let's write a function for it. Right, this one can say for row in board, print the row. Now, this isn't even the prettiest version here. We can come back and make this prettier as we go, right? Because usually you have your lines. So if we wanted to print the lines here, right, we can say, how about, let's do, we did some fancy things with this, right? So I can say, I want to take a 9 dashes, right? No, 1, 2, 3, 4, 1, 2, 3, 4, 5 dashes, right? And I can join together the board, right? That will join the rows together with this, right? And a new line character. Oh, this is going to be a little ugly here. But I don't even want that. I need each individual row out as well. For row in board, I want these to be joined with a, this gets really ugly, I'm sorry. Join row, for row in board, join with that. And then this is print all of that. This one might work. I don't know. We'll see. It might work. It might be really ugly. We'll figure it out. But I want to take each row, put spaces in, and then separate those with dashed lines. We could do it the hard way too if we wanted. Should we do it the hard way? We can do that. We can print board of 0, 0, right? And then I want to append in here a space separator, right? That'll type character. And I want to append in board at 0, 1, right? And then append in the pipe character, and then append in the board at row 0, column 2, right? And I want to print all the dashes in between them, right? And then print that, print all the dashes in between them, and then print the last one. Right, so this is row 1, this is row 2, row 1, row 2. Does that make sense, what we're trying to do? Right, so print them out a little bit prettier here. So we separate our characters with all the dashes. Make it look like a tic-tac-toe board, essentially. Oh no, we need lines in here? I don't know, dashes are probably fine. All right, so anyway, so we'll print the board, then we'll get the row, we'll get the column. And then while my board at row, at column, does not equal a space, that's an invalid move, right? So we'll print invalid move, and it'll ask for more input again. Now we could even check too, would be nice, like if the 0 is less than or equal to the row is, I'm sorry, row is less than 0, or row is greater than 2, or the column is less than 0, or the column is greater than 2, or this. So if you give me an invalid row, or you give me an invalid column, or there's not a space there, it's invalid, try again, right? So this is checking to make sure it's a good row, checking to make sure it's a good column, checking to make sure it's not an empty space here. Okay. Eventually, when this loop is done, I know I've got a valid row and column, and I know that it is a space character. So I'm going to take my board at the row, at the column, and assign the value of the current player. Right? We're going to assign the current player there. So I make a move. I know it's a valid move, right? And then I'm going to take my current, if current player is equal to X, then current player equals O. Otherwise, current player equals X. Right? So if you are an X, flip to O. If you weren't X, you must have been O, flip to X. Right? This is a useful case for those ternary expressions. I can say current player equals X if current player equals O or something like that. I forget. Otherwise, else X uh something like this. I forget. These are ugly. I hate these ternary expressions. You remember these? I looked at them briefly. It's like a one-liner essentially for these. I hate those. Um, so this is more lines of code, but sure. All right. So while the game's not over, make a move, change the current player. Make a move, change the current player. Make a move, change the current player. Eventually, the game will be over. Right? That's it. This is our tic-tac-toe game. Right? Where's my board? So I need current player and board. Let's move those up. So we broke it down into a bunch of functions. Right? All we need is our board. We need our current player, and we can play tic-tac-toe. Should we try it? Hey, look at that. It printed out kind of pretty. That's what I was hoping for. All right. If you guys can beat me at tic-tac-toe, you get an A in the class. Give it a try. Tell me where you want to go.
That,
The center one? So what's the row and what's the column? Row one, column one. Okay, so you put an X in the center. All right, well, I got to go in the diagonal, so I'm going to do 0, 0. Okay, where are you going next? Row one. Okay, column 0. Okay, well, I got to stop you here, so I'm going to row one, and I'm going to column 2. I blocked you. Where are you going now?
zero,
Row 0, column 1. All right, so now I got to go here, so I'm going to row 2, column 1. I blocked you. Where are you going now? Row 2, column 0. All right, you got 2 in a row, so I got to go here. So I'm going to row 2, column 2. Blocked you here. Now you got to go here, right? You're at 2, 2. Game over. Cat's game. So I guess we should print out the board one last time when we're done here then, right? So it's one last time we'll call print board. Given the board. I don't know, print game over or something. Game over. You print the board out. That'll be a little prettier here. I'm just going to call print just to separate these. Should we try again? I'll give you another try. If you can beat me, you get an A in the class. Yeah, where do you want to
it's for,
go? I'm sorry? Okay, you want me to start? All right. 1, 1.
row zero,
Okay. So let me go. Uh, I'll go 0, 0.
row three, column,
Okay, you blocked me. All right, so I got to block you now. So row 1, column 2. Where are you going? Okay, you blocked me. All right, well, you can't win now, and I can't win either. I guess I can try, right? Then I go 0, 1. Look, I got 2 in a row. I'm gonna win. I'm gonna win. Where you going?
I don't know. Did you?
2, 2.
No.
Invalid move.
One.
2, 1. All right, well, you got 2 in a row, so I got to go 2, 0. Cat's game. Game over. You can't lose a tic-tac-toe. My kids hate playing tic-tac-toe against me because I never let them win. My wife says it's mean to not let them win. I don't know why that's mean. Like you're not always going to win. Is that are they too young to learn that lesson? Like you're not always going to win everything. They refuse to play with me now, that's fine. Right? They win at rock paper scissors because they know my strategy, but they don't beat me at tic tac toe. They hate. I'm like, hey, I'll give you $100 if you beat me at tic tac toe. They used to take me up on it all the time, and now they know there's just no winning. Right. All right. So we made tic tac toe with a list of lists, right? Two-dimensional list, and we broke it down. Right. Functional decomposition, one thing at a time. One thing at a time. Right. Sure. Make move. Now we could, if we wanted to get even fancier, we could break this down too, right, into further steps, like is row valid and is column valid and is location empty. There's nothing wrong with that. And then it makes this a little easier here to break apart, I guess. Right? You don't have to do it all at once. Like we could have for any of these, like, did someone win? We didn't have to do three different functions. But breaking it into three different functions made this one smaller, and then each function was a little bit easier to write. Right? We could have just done this and said this or this or this, right? Or done this and then done this and then done this one. And we could have done any of those. Like you don't have to turn them into functions, but let's just break it down into a smaller problem. Right? So it's a little more concise, little smaller package to tackle, small problems at a time to tackle. I sort of like. Okay, that's tic tac toe. All right, you guys think you could do connect four? That's a 7 by 6, or no, 6 by 7, right? 6 rows by 7 columns. Connect four, and you have to win by getting four in a row. Now that one's actually is a solved game. If you know what you're doing, you cannot lose if you go first, which is super interesting. So yeah, yeah, it's solved. How to always win at connect four. How to always win. Uh, WikiHow. Sure. The strategy will keep you on top. Things you should know. Sure. Put the checker in the center. All right, always in the center. Place your checker on top of your opponent if you're second. It doesn't matter. You're always going to lose. Control the center column. No. What's the... No. No. There's a formula here. What's the formula? Connect four solver. In English. There we go. Red can win in 21 moves. There we go. Show the solution. That wasn't a solution. I don't I don't know what just happened here. Am I supposed to put it in here? Yellow loses in 21 moves. So your least losing move here is this one, I guess. Your best winning move is here. The least moving move is here. Best winning move is here. Sure. Least losing move is anywhere. Doesn't matter. Okay, sure. Red. Next one's here. Sure. Yellow has to go here. Red has to go here. Right? -1 for yellow, +1 for red. -1 is either side. It doesn't matter for yellow. Which one should we do?
Right.
The right one? Okay. And then a +1. Either of these columns will win us. That's fun. Sure. How about we go here? All right, yellow, left or right?
Right.
Right? Oh, I'll show the solution. There we go. So red has to go here to block. Sure. All right, yellow, left or right of these two? Okay. Red, this one or this one, left or right? Oh, or this one here. You have three options. Left, center, right. Far right. Oh, I keep clicking the wrong thing. Okay, yellow. Anything but these ones. This one.
Right.
Far left. Okay, red, it's got to go here. Yellow, it's got to go here. Red, we got three options here. Where do we want to go?
Yeah.
Middle. Okay, yellow's got to go here to block us. Red's got to go here. Yellow's got to go here to block us. Red, left, center, right.
Right.
Okay, yellow's got a lot of options.
Right.
Far left. Right. Red's got to go here. Yellow's got to go here. Red's got to go here. Yellow can go anywhere. It's all sad for yellow. Far right. All right, red can go anywhere. Nice. Far right. Yellow can go anywhere. We'll go far right. Red can go anywhere but the right, right? Because we're waiting for yellow to go here, right? We're going to force them to go here so we win at this point. So anywhere other than here we can go. This one, okay? Yellow can go anywhere but here. Doesn't really matter, right? We'll go here. Red can go anywhere. Doesn't really matter. Yellow can go anywhere but here. Let's try and win, right? So red has to go here to block them. Yellow has two choices. So yellow goes one place, red goes the other. Yellow has to go here, and red wins. Right? It's a solved game. You can't lose if you know what you're doing. Just crazy, but sure. Do you think you can do Connect 4 for lab? The list of lists? Break it down, right? Same idea here, right? We make a board, and then while you can make a play, or while the game's not over, means there's an empty space, or someone has not won, right? Or if someone did win, the game is over, right? So winning here is a little trickier, right? Winning means, again, same idea, break it down. Did you win by column? Did you win by row? Or did you win by diagonal? So the diagonals we have to turn into a loop, right? So to win, now I break this down usually diagonally down and diagonally up. So to go diagonally down, I know it's four in a row, so there's only three starting rows you can have to check, right? Row zero, row one, and row two, because going downward, right, means I'm going down a row, down a row, down a row. So the furthest down I can start is row two to look for a diagonal downwind. So I'm going to check these, this one here, this one here, this one here, and this one here. So there's only four diagonals you check each row, right? To check diagonally up, right, it's the same thing, but I'm going to check rows three, four, and five going upward as I go, right? And that's columns zero, one, two, and three, and four, right? Because you can't get further than column four to win diagonally this way, right? So you start with a limited subset. So it's just restricting your row and column where you start and increase or decrease, right? So diagonally down, your row increases as your column increases. Diagonally up, your row decreases as your column increases, right? Other than that, it's the same idea, right? You just build the board out and you do it. So this sort of format is not going to work as well for you. Oh, I wanted to see if this works. That's right. Let's see if the printing here worked. Something like this ought to work for us here. I think. Oh, no, okay. So I need one more new line there. So join type row in board. I want to take the row. I want to add a new line to it. How do I add a new line to it? Oh, I can just add a new line here. There we go. Let's start a new line. I think that ought to do it. Hey, it worked. Okay. So this one liner, right, using string joins and using this list interpolation stuff, I hated this when I started Python. It's been several years, so I got comfortable with this. So this is probably easier to start. If you like one-liners and you like puzzling them out, this is fine too. It's okay. So we're saying take this and join every row, and every row is joined, every value in the row is joined by the type character here. So anyway, that's it for that. Okay. So let me commit this to GitHub here. This is our tic-tac-toe. Toe. All right, and we'll go to lab. We'll work on Connect 4. So we'll practice some functional decomposition. We'll practice working with lists of lists and indexes of rows and columns and build it all out. It's essentially the same thing, right? While there isn't a winner, right? Have someone make a move and then flip red and yellow or however you want to call it. You can do X's and O's too. It doesn't really matter if you want to change those or not, right? And then the next player moves. So figuring out if it's a valid location is a little bit different, right? Because you don't ask for the column, you just ask for, or I'm sorry, you don't ask for a row, you just ask for the column, right? So this is a valid column because there's a space here. None of the other columns are valid because there's not a space. Or you can check, hey, is there a space at the top? If there's not a space at the top, no, you can't go there. If there is a space at the top, you're actually going to put it down at the lowest space. So sometimes it's easier to start at the first row and say, hey, if it's not blank, or I'm sorry, if it is blank, put your mark there. If it's not blank, go to the next one. If it's not blank, go to the next one. If it's not blank, go to the next. You got a couple options for how you put your marks in here, right? But because they need to go to the furthest down row, you kind of want to start at row five. And if it's not blank, put it in. Or I'm sorry, if it is blank, put it in. If it's not blank, go to the next one. If it's not blank, go to the next one. So it's a little bit trickier for how you make your mark, but definitely doable. Okay. All right. Oh, it's 1:45. We folks did great.